Hello, my name is Chris, and I'm demonstrating the Umbra Wallet Gateway, which is a combination of a privacy-enabled, network-enabled demo wallet and a privacy-preserving RPC gateway. The project is built on Helios in the wallet, so it maximizes the amount of locally created calls, so nothing is going out over the network. For the calls that do have to go over the network, such as send transaction and any state call, the wallet will proxy over the Onion network to the gateway. You can see here we have status bars towards running, but it's not connected. We also use X402 as payments on the gateway so that you can pay the RPC provider, but not have to sign up for an account or put in your payment information, anything like that. And we have a network status that shows that we're not connected to base Sepolia. So let's connect to the Onion address, which is the gateway here. As it's spinning up, it connects to the gateway and it's negotiating the X402. Once it negotiates the X402 payment, it then updates the balances. So you can see the call here. As it's submitting the payment, as we initialize a light client, you see that we make the calls for the ETH call and the ETH get balance, and we're probing for the X402. Once we get the X402 negotiated and paid for, a token is issued, and we submit all of the calls to the provider, which then provides us our data. This works over the Onion network, and these are through Helios, not directly from the wallet. We've got a little tester here as well, so you can see that the calls like get chain ID, they return a valid JSON RPC payload, and also they don't leave the network. That one's going to Helios. Gas price, also Helios, the gas price returns. Get balance is a little different since it's a state call. When we issue this, it does go through Helios, but Helios does a get proof call, which goes over the Onion network to verify that the information is correct, and then it returns the amount of ETH that I have. That's it for the wallet demo. Now let's take a look at the network activity and see what that looked like. While I was running that demo, I had a couple of scripts running using Wireshark to sniff the traffic coming on and off my computer. The top shows what's leaking out on the public network, and the bottom shows what is the activity that's happening on the Tor network, local to the computer. As you can see in the top pane, when the wallet boots up and starts connecting, it makes calls to the operationssolarstorm.org. That's a bootstrapper for Helios, so it can get the context for the consensus and bootstrap very quickly. You then see the gateway calls, the X402 facilitator, and then the call into sepolia.base.org, right, the public base RPC. Now on the bottom here we have the Tor observation. You can see that there's local traffic going from the app, which is the 9050, and back. And that's all of the RPC calls that's breaking up, going over the Onion network, going to the gateway, and then coming back. So all of those are privacy preserving in the fact that the gateway never receives the user's IP address. And you can see that all of these calls here, this was a call broken up by these bytes 3-2. You can see the traffic going back and forth from the Onion network and back into the wallet. That's it for the demo. It really showed the point was to really show that we're preserving the privacy stack at the RPC layer, which is often overlooked when you're operating a wallet over public networks.